This meeting is being recorded.
Tervetuloa tähän Zenergia-järjestämään Ferroamp-webinaariin, ja tosiaan tämän päivän agendalla meillä on Ferroamp ja Smart Electricity Control, eli mitä kaikkea Ferroamp-järjestelmä mahdollistaa ja mitä kaikkea siihen pystytään liittämään ja miten sitä pystytään hyödyntämään. Niin siitä ollaan täällä kertomassa, eli minä, Kalle Salli Zenergialta, sekä sitten Torbjörn Wolf Ferroampilta. And this Torbjörn is from Sweden, so this is partly in English, but if there's any questions you can write those in Finnish in the chat. Ja tosiaan sisältönä meillä on vähän, että mikä tämän Ferroampin tausta on. Eli tämä ajatus tästä, että focus on power, not only energy, niin siitä kerrotaan hiukan enemmän. Sitten ihan Energy Hub, mikä toimii tämän järjestelmän keskiössä. Sen jälkeen, mitä nuo kummalliset kirjainyhdistelmät SSO ja ESO ja ESS ynnä muut tarkoittaa. Sitten hiukan mitä Power Share Technology, mitä se tarkoittaa, DC Nanogrid, se kokonaisuus, mikä on mahdollista toteuttaa tämän järjestelmän avulla. Ja sen lisäksi sitten ihan toi Energy Cloud, mitä sieltä pilvipalvelusta saadaan tietoa irti, mitä sieltä löytyy ja miten sitä pystytään hyödyntämään, jotta saadaan kiinteistön sähkönkulutus niin sanotusti omaa hallintaa ja se tehot sieltä oikeisiin paikkoihin. And now we start the English part, and I let Torbjörn take over the screen and voice, and like I mentioned, kysymykset voi esittää chattiin myös suomeksi. But Torbjörn, you are most welcome.
Thank you. Thank you. I think you need to go off your sharing to let me share.
Yes.
Yeah, you are. Exactly. So, can you see my screen?
Not now we can see.
Now you can see. Right. I just need to hang on. I need to full screen. There you go, I hope.
Yes, now we can see.
Perfect. Okay, thank you for inviting me, Kalle. Really nice to do this again. It was quite some time since to have a common presentation and meeting, so that's appreciated. Well, Ferroamp, we are a Swedish technology company. Very often we're into solar installations, also for battery or car charge. So as you can see, we have won several awards, which is very nice. We started, the company started 2010. It was the first commercially products came out about 2014, and it really took off in 2018 and 2019, but even more so when the energy prices increased a lot during 2021, 22. So then the whole solar industry took off, but even for us at Ferroamp, even more so. So a lot of our thoughts are taking control of the grid connection and also the total grid cost, not only the energy, but also the power. So here is a screen of the development on prices just on the grid cost, the grid connection. So depending on which grid owner you have, it will be different, obviously. But as you can see, from 2014 to 2019, it has increased a lot. It's a huge increase. So therefore, you also want to have the possibility to actually take control of this cost. And in Sweden, I think it's the same in Finland. Kalle, you can hopefully let me know if it's not, but you have the different cost and different fuse levels. So in Sweden, we have 16, 20, 25, 35, 50, 63 amp different levels, and every level has a different cost. I'm not really sure how it is in Finland, but maybe you can tell me, Kalle.
Yeah, I can tell. I can actually take this a little bit Finnish and English. And, eli tosiaan niin kuin yksi sellainen asia, mikä ei välttämättä tule kiinnitettyä niin paljon huomioon, on se, että paljonko se liittymäkustannus on, mikä sen ihan fyysisen liittymän maksu on, mitä se maksetaan pelkästään niin kuin perusmaksuina, että mikä on riippuvainen siitä liittymän koosta. Ja tietysti isommissa liittymissä tulee kaikki tariffimaksut, sun muut tehopiikkimaksut, niin ne on ihan merkittävässä roolissa siihen, että miten pystytään esimerkiksi tällä Ferroampin järjestelmällä saamaan myös kustannussäästöjä. So I think they are quite same here in Finland, like you have there in Sweden. Like we have different levels for different kind of fuse sizes, and basically the lowest point in our system is 23 times 25 amps, and then there goes up to that, and in some point is it around 80 over 80 amps, like 125 amp fuses, then there is probably start come some kind of tariff cost for when the peaks what you are producing. So, but in the smaller levels, there is in some points quite big gaps.
Yep.
And I think also because there is like old buildings what have like where have done some modification, for example, some industrial hall, and you have changed the luminaires for LED versions, and then you might have big grid connection, but you don't even probably need that much. But I think you will tell more about that, what you can do about it.
Exactly. So one of the things that Ferroamp has is a phase balance function. I'll just come to that in a bit. So from our perspective, even more so before the energy cost became so increased than it was. We have been about 0.03 euro per kilowatt hour for many years. And so that was not so much to save on for a villa or a smaller commercial resident building. However, on the grid cost, it was quite a lot. So we have always said focus on power, not only on energy. We also have more DC powered things, or possible to power DC, but you have the solar is DC, regular battery for home storage is DC, the car battery is DC, LED is DC, a lot of ventilation can be driven on DC, so we can actually put in this in our system as well. But there is a shift in generation. As in the phone business market, you all probably remember this Nokia phone. I had exactly one of these. It worked splendidly. It worked very good. But it has changed to smartphones. So I actually don't know anyone who doesn't have a smartphone, even though sometimes you meet someone who has an older phone. And the same thing is in the PV or solar industry. So traditional PV is quite simple. It has been working for many years, obviously, longer than Ferroamp has existed. You have solar panels on your roof. You have a converter, and that converts from DC to AC. So the house becomes a sort of a chassis like a car. And then you have a solar panel, which is the engine or gives the energy, and you have a converter that is the sort of gearbox, and it works very, very good. You get the energy into the house, and that you don't the energy that you don't use, you will probably sell and get paid for. So that's very good. Ferroamp, though, we take it to PV 2.0, that we say. It's the same thing with the chassis. The house is the chassis, the solar panels gives the energy, sort of the engine. The converter is the gearbox, but we also have a measuring system as a standard. We're very, very high resolution in a very good portal where we can see everything, how everything is in the house. We can do analysis, and therefore we can start to sort of steer what we want to do or decide what we want to do. So the energy hub, which is our sort of converter, a multiple function device, is the steering wheel. We can see where we are. We can also decide where we want to go, and then go there by doing analysis and take control. So one of the energy hubs is for 14 kilowatt. We have different sizes, obviously, but it looks like this. But here you can use it as a standalone, or you can add battery, add a solar panel, and connect it together with several different energy hubs and create a smart power share grid within the normal grid. So one of the functions then is that we can actually move energy between the phases. So it could be like this. This is, for example, it doesn't matter really if it's 63 amp or 25 amp or what number it says. We can do the same. So in this case, you actually need the 63 amp, as you can see, but the phase 1 and phase 2 is probably down at 25 or maybe 35. So it's a lot of unused space in phase 1 and phase 3. And that is what we actually, with the energy hub, use. So we can take control and use all the 3 phases equally against the grid, so against the main fuses. The unbalance that you can see here between phase 1, 2, and 3, that's within the house. That we can't do anything about unless we start to reconnect the wiring and so on. But towards the main fuses, that's where we can balance out, so it's more even, and therefore we can lower the main fuse and therefore also lower the cost. So in my own case, in my own house, I have an electrical car. I have, well, dishwasher, well, everything that you have. But I also have a spa, and the electrical heater I can't control, because when the temperature drops below whatever temperature it should be, not 39 maybe, that will kick in, and so it doesn't matter what I do in the house, I will have this unbalance. So I needed before the Ferroamp 25 amp, but with the Ferroamp and this phase balancing function, I can have now 16 amp, and in my case that's a saving of 300 euros per year. So that's one of the things. And then obviously, depending on where the different levels is, if there is if you go in, as in like Kalle said, from 63 up to 80, at least here in Sweden, you go from a fixed cost to a fixed cost plus power tariff cost. So if you have 80 or 100 or upwards, you will have the fixed cost, but you also will pay per kilowatt that you use as a maximum average hour per month. And that cost could be quite a lot. So depending on what grid you're connected to, here in Sweden, it differs between 38 Swedish crowns per kilowatt that you use up to 125 Swedish crowns per kilowatt. So that could become very, very expensive. And then the whole system that we are using could take control of that as well. But if you have a fixed main fuse and fixed cost, you actually have the possibility to take control, even it out towards the main fuses, and therefore lower the main fuse level and also the cost then. So this is how it, for instance, it actually works. So on the right side, you can see the house and the consumption. That is what it is. We can't really change anything in this system or in the house, but you can see the difference between phase 1, phase 2, and phase 3. And here the phase 3 will pass 80 amp for a few short moments, but at least it's quite high. But phase 2 is only having 22, 23, 24 amps. And that's where we are using. We are taking out more on the grid side, loop it through the energy hub, where we shift it from phase 2 to phase 3. So we can not, we will still get everything that we need in the house, but towards the main grid or the main fuse, we have changed, so we have a more even takeout, and therefore we can go from 80 or maybe 100, depending on what the house has, down to 63. Here in Sweden, that's quite a significant cost reduction. So that's how the system works. And by doing this, we need to measure, of course, but we also go from DC or from AC into the energy hub, where we convert it to DC, move it from one phase to another, and convert it to AC again, and send it out to the phase that is needed. So we have a bi-directional converter, and then we can also include PV or solar installations because we are a converter. However, we need to, in our case, install solar string optimizers. To those optimizers, you're connecting the solar string. So from something 3 to 20 solar panels. And what the solar string optimizer will do is that no matter if it's 3 panels with, for instance, about 100 volt, it will boost up to 760 volts. If you have 20 panels, it might be 700 volts. It will still boost up to 760 volts. So every solar string optimizer, if you have different directions, you have different angles, different lengths on the solar string, it will be 760 volt that comes out from the optimizer. That gives us a possibility to just connect all the parallel connect all the optimizer into a connection box, and this can be on the roof or up in the attic or where you want to put it. But from this connection box, we only need one cable that goes to the energy hub or the converter. Also, when we have this DC string of 760 volt, we can connect a battery. So there we have several SSOs or solar string optimizers, but we can also increase or connect a battery. In the battery, we put a Ferroamp product as well, which is called ESO, Energy Storage Optimizer. And what does that ESO is doing is actually boosting up the battery voltage from, for instance, 560 or whatever it could be, up to 760. That means that we could connect the battery to the DC string directly. And we also go from this ESO also takes it down from 760 down to, for instance, 560, if that's what the battery is having. So we can actually charge the battery straight from the solar strings. In the future, we will probably see a DC charger. Today, the cars talks with different protocols, so different languages, so to speak, which makes it difficult to have one single DC charger that talks to everyone. As a DC-DC to charge is not a problem, but what you want to do maybe is actually use the car battery into your system, and that's where you need to be able to talk to the battery, so you know everything that what the car needs or has to and needs to send the energy out. Is
To
there any
Björn,
questions about that?
yeah, I have a yeah. There's a question regarding. If I remember correctly, was it last year? There was announced cooperation with the Ferroamp, CETEC, and Polestar regarding this capability to use a DC site for charging. How is that going at the moment?
I think we have been in several different projects, but I think also we haven't focused on bringing or launching a DC charger for only one car brand. We need to have several car brands, so even Tesla or BMW or Volvo or Polestar or Kia or Hyundai or whoever is on the other side, because it will be too expensive to develop one product for one brand and then another product for another brand and so on and so on.
Yeah.
So we need to have something that we can not to charge the battery in the cars is not a problem for DC. It's to take out the energy from the battery. That's why it's more problematic. I think that we will see a change also obviously from Ferroamp, but also on these different car chargers that will show up on the market in probably in the near future. Because I also think that more and more cars will open up their protocol so they have a standard, but we're not really there yet.
Yeah.
So that's.
But you have there is made some tests probably regarding that those functions.
Absolutely. Yeah, it has been on a test phase, so to speak. So we know that it could be working. But to start to produce sort of a mass production, we need to know that we can talk to more than one car.
Okay. And
so
another question now, when you take those ESOs, battery systems, what about the capability to, is there already function that those ESOs can be used in the off-grid situation then when the grid is failed? Is that already possible or not?
No, our system is not backup ready or off-grid ready. So if the grid is going down, the energy hub will go down, and therefore also the whole system will go down today. So I think not to say too much, but I think in the future we will probably see a change in that, but I can't say when. But today the system is not off-grid or backup ready, even if you have a battery. So that's
so in that way it works like basically all the brands.
Yes, the most. Yeah. If you really need sort of a backup, then you can use Ferroamp for the bigger picture. They could take control of most of the things in the house, and then you can have a smaller converter that is backup ready with a battery, for instance, because that battery will charge even if you don't have any sun, but also take the sun that comes from the Ferroamp system. So that's the way to do it if you don't want a generator for petrol or diesel or something like that. So, but today our system is not backup ready.
Yeah. Okay, that's good. But we can continue.
Yeah, no problem. Just keep asking if there is anything. So that's this picture gives us or gives you a bit of a how the system is built up. We are building a small DC nanogrid where you could connect solar panels, battery, in the future DC chargers, hopefully, and so on. And everything is on 760 volts, so that is quite unusual. With the batteries, you can actually use them obviously as a backup. Well, not in our system, but some people are thinking of backup. But even more important maybe is actually to take control. Either you want to charge it with the solar that you get, and then use the battery during nighttime, and that works obviously. But you also can use it actually to peak shade. And in this case, you can see the blue peaks. That's what you actually are using. The yellow is actual sun, and there you can see when the sun starts to come up and give more and more, the consumption lowers because people are going to work or schools or whatever. And we start to charge the battery, which is the green below the basic line. And when the battery is full, we are exporting to the grid and get paid. And then when the sun goes down in the evening and people are coming home, the battery starts to be used, and that's to get this black line where you can see it's quite flat. So this is a resident building in Sweden where they have decided that this black line is where they want to, that's what they are willing to pay for to the grid in cost of grid cost, because they have a power grid cost as well. So in this case, we can take control of this to the black level, but not further. How much that is in savings depends on obviously what you're paying to your grid owner and everything. But this is one way of using the battery, which, so the way you will use the battery is probably depending on where you get most profit. That's the most common way. So yeah, Kalle.
Yeah, I have to mention that this is actually the, I think, most intelligent function of this system. So maybe I speak a little bit about Finnish regarding this and clear also that way this function.
Yes, absolutely.
Eli tosiaan tämä on niinku yksi tämän niinku Ferroamp-järjestelmän mun mielestä niinku älykkäimpiä ominaisuuksia, eli on nimenomaan tämä peak shaving. Eli mitä se niinku tarkoittaa tässä yhteydessä on just se, että sillä akustolla ei yritetäkään saada sen koko kiinteistön kulutusta katettua, vaan se on optimoitu noiden kulutuspiikkien tasaamiseen. Ja se oikeastaan tuossa Energy Hubissa toimii kahdella tavalla, eli siinä on se akusto, kun se liitetään järjestelmään, ja sitten sen lisäksi siellä on myös se load balancing mahdollisuus. Eli kun tätä monitoroidaan, eli katsotaan, mihinkä se power menee siellä kiinteistössä, niin sen monitoroinnin avulla pystytään katsomaan, hyödyntämään se kuorman tai vaihekuorman tasausominaisuus, ja sen lisäksi se optimoimaan se järkevä akuston koko siihen, että saadaan katettua ne korkeimmat kulutuspiikit. Eli saadaan järkevän kokoinen akusto sinne, saadaan minimoitua verkosta ostettava sähkö, ja sehän myös sitten tietysti kertaantuu siihen, että samalla lailla kuin auringolla, eli jos sä saat siellä auringolla ladattua sitä akustoa, niin ihan yhtä lailla sieltä jää siirrot ja verot. Niitä ei tarvitse maksaa, jos sä tuotat sen siellä omassa kiinteistössä sinne akustoille. Ja tämähän on ehkä sanottava se, että tosiaan tässä me on puhuttu aika pienistä järjestelmistä, mutta täällä pystytään toteuttamaan myös isompia. I Torbjörn mentioned now the last also about that now we have talk about also that quite small scale solutions, villa residential solutions, but I mentioned that we in this system can be scalable in quite big levels also, so the listeners can think about also a little bit bigger sites, how to use this kind of functions, because there is a capability to send also lots of kilowatts out from the batteries, not only the kilowatt hours, but also kilowatts that they can truly use this peak shaving function. Even the bigger buildings, for example.
Yes, absolutely. That's a very good reflection, Kalle, because depending on what your purpose is, but if you want to peak shave and use a lot of power, kilowatts, there is a lot of batteries that has the function of maybe 15 or 50, whatever, kilowatt hours. But when you want to use the power that is the kilowatt, it might be only for a 15 kilowatt hour battery, you only get 55 kilowatts. That could be used for 3 hours, obviously, but it also might be better to have a battery that is can be used with a lot of higher power. So in our system, we have a battery that is 28 kilowatt hours, but you can release 24 kilowatts. And that obviously will only be for just more than an hour, but that might be exactly what you need. So when you're thinking of the whole system and your setup, you need to know or think of what is the purpose of the use of the battery and what sort of battery capacity do I need. So, but that's correct. The other way around, where you can actually, when the battery is very, very functional, it's not always, even though most of the times will be for the cost savings, but sometimes there is that the grid doesn't cope or can't handle the extra capacity that you want to get out of the system. So, for instance, if you're in the countryside and you have a villa and you have the 25 amp, but you have a spa, you have a sauna, you will also install a car charger and so on. The 25 amp might not be enough. Then you can install a system, Ferroamp, including a battery to support your system when the grid is can't handle what you want to get out of it. That's not as often as the situations where you actually want to use the battery for cost saving or peak shaving, for instance. So, but that's there's different ways to use the batteries. Obviously, that's the main point. So when we have this system then of 760 volt that we have solar, we might have battery, we don't have the car charger. We can actually connect different buildings together, which we are calling power share technology, that we're actually sharing the energy. So Ferroamp, I would say, have two very, very unique functions where we are alone in the world. The one is phase balancing, that is shift between, so we can even out the consumption towards the grid and therefore lower the grid fuse and also the cost in the best case. But also the other unique function is where we can connect different buildings together, and we do that on the DC side. So in this picture, for instance, we have an internal DC grid. So in this case, we have 3 houses. Every house has their own grid connection. So we need 3 different energy hubs or converters, but as we call energy hubs. We have solar power on 2 of the buildings, because the third building might have not have a roof that is good enough or facing north or whatever, but as an example. Since we are building in the 2 buildings with solar string optimizers, we will have 760 volt in both those buildings. By also connecting an energy hub to the house without solar power but their own grid connection, we're putting in an energy hub. We can connect all the 3 energy hubs on the DC side, and therefore we also can share all the solar power within the grid connection or within the DC grid, nanogrid, before we are exporting it out to the normal grid. So instead of having 3 different silos or 2 different silos, because the third one doesn't have any solar, we can share the solar power instead of having a silo where we are using what we are using and everything else is exported to the AC grid, and do a U-turn to where we have to buy it into the building with no solar, for instance. So, and we can also share one bigger battery if we want, instead of having 3 batteries. So this makes that gives us that we will have much more or higher self-consumption of the produced solar power. We can also use the different grid connections if there is power still unused in house 1. We can take out to the maximum level of what the main fuse can allow, and we can share that to another grid connection where it's we need to get out more than we actually have the possibility in another grid connection. So we can share both solar, we can share batteries, we can also share the different connections by sucking out or taking out more from the AC side if there is something left, and give it to another one where it's needed. So this is actually something that we are increasing a lot here in Sweden. I think we today have about 120, 125 energy or power share situations or housings, and it's increasing more and more. So technically, this is not a problem. We've been doing this for several years. What you need to think of is where it's allowed, and that it may differ how the rules are from Sweden to Finland, and Finland and Norway and Denmark and so on. So I'm not really sure here, Kelly, if you can if you know more how this is allowed in Finland.
Yes, I think the key thing here is that in the system-wise this is possible to build, but I think at the moment it's not allowed to transfer energy to different grid connection to another, and that's the main thing. But I think there has now discussions and tests going on in the few locations that because Energy Hub has a function that it can be set up in that way that it doesn't transfer energy to grid side to DC side, if I'm understood correctly.
Yeah.
Yeah. So in that way,
I know there.
If there is if that function is blocked, basically, then there is a separate DC grid, and then you don't transfer energy to grid connection to another. But I think also this function can be used inside of one grid connection. Also, if you have separate buildings, for example, housing companies or that kind of places where if you just build separate solar systems, and maybe there is roofs, or then there is no space for solar for inside of some buildings, but then you can transfer through this nanogrid. And actually, I think it's good to mention that when you are using DC grid, you can use smaller cable sizes quite often than if you are transferring through the AC grid.
Absolutely, and that's a very good reflection, Kalle. That's that since we are boosting up voltage to 760 volt, most often we can lower the power, the amps. So we use less copper, so the cables will be, as you said, smaller and therefore also cheaper and more easy to handle depending on situation, obviously. So in our case, when we are using this for and putting up solar, the solar string optimizers will be on the roof or up on the attic, depending on. But if you're as a commercial resident building, with a lot of flats, you will have a much smaller cable going through the whole building to the cellar or wherever the main electrical central is and where the energy hub is, instead of building a electrical central in the attic or in a special room on the top of the building where you're connecting the solar strings on a traditional converter. So absolutely, the cabling will be smaller, and there is we can go through this later with the cable calculator and also the SSO calculator if you want to.
Yeah, I think that could be separate, but also I think in that case is also good to mention, because we have had this week a webinar with the fire department, and they present their instructions a little bit, and I think also one function in this system is that when you have these separate SSOs, these solar string optimizers, wasn't that so that you can like cut the connection between the energy hub and SSOs, and that it's that there isn't any voltage.
Correct. Yes, absolutely. The system is that for the optimizers to deliver any energy or any power, it has to be connected to the energy hub. So if you're even shutting down the energy hub, or you're shutting down a DC breaker on the DC side, the connection between the energy hub and solar string optimizers will be interrupted or cut, and therefore the solar string optimizer will shut down and not deliver. And the same goes for the battery. So the ESO needs to be connected to the energy hub. So if you can have if there is any demand from the fire department, for instance, or whoever would like to have it, you put a DC breaker quite close, probably, to the energy hub. You can also put a fireman switch, which in turn has a emergency breaker somewhere where you push and the system will shut down as well. So it works like if you would have solar or panel optimizers, which do the same thing, but we have string optimizers. So that's correct.
Yeah.
So then you can get the total DC shutdown. So because the solar string will deliver power and energy as soon as the sun goes up, and therefore when you have the solar optimizers, solar string optimizers, you would like to have them as close to the end of the solar string as possible. Quite often, if you have a villa, that's how the installer and maybe the house owner decide to have it. But in a villa, quite often the solar string optimizers will be placed or are placed quite close to the energy hub. But you can have it in hello, Kalle?
Yes, I'm here.
Okay. Everything just sort of died. I thought, is it my computer? No. So you for the best safety, you put the solar string optimizer as soon or as close to the solar or panel string end as possible. So then you have a safe grid.
Yes, that's good, and I think it's a good thing to mention that this does this function.
Yep.
Also, that if you're disconnecting the energy hub, then it's do the shutdown for all the DC grid also in the same time. So
yes. Yep.
Basically, you just need to switch AC switch off, and then also the DC side is off to the SSOs.
Same thing. And that's because if you're when you're turning down the energy hub on the AC side, it will go in a sleeping mode or die, and then will not have any connection with the SSOs or ESOs in the batteries, and therefore the whole DC grid will be shut off as well. So that is exactly as you say, the same function. So yeah, and this is sometimes with the DC grid that depending on situation, obviously, but as I said, it's this is a case of the Vasakronan, which is a building owner in Sweden. This is in Uppsala. They have had 3 buildings with solar panels before, but they changed to Ferroamp converter and added a 4th building and added 60 kilowatt of the power on the roof, and everything was going into the power share, so they had 100% extra self-consumption. So in this case, it was very they had very short payoff time, since everything went in. They didn't have to buy. They actually saved about 60,000 kilowatt hours from buying from the grid instead of it from the own solar production. So so depending on how it looks like and where it is and situation, the payoff time will vary, obviously. But here you can always contact Kalle or me or us at Ferroamp, but probably through Kalle then or Synergia, and we can help you to see what is the best way. So the power share advantage is you can have larger installations of the best of the roof instead of have all the roofs. You can share the batteries or the PV for self-consumption, power control, backup in the future. We are not there yet, obviously. And you can also share loads. Therefore, you can, which is depending on where you are in, it's probably not allowed than in Finland, but we actually can take out more from different connections and share between buildings. So that's about it for this is a shorter presentations, obviously, but I'll gladly have questions if there's any more questions of power share or the system, and we can also go in more detail if you'd like to. Are you there, Kalle?
Yes, I'm here.
Yes. Yeah.
Now I try to be moderator here, but if there is any questions, niin nyt voi kysyä kysymyksiä ja tosiaan kirjoittaa, mutta thank you to Björn for this presentation. I think Ferroamp here in Finland is still quite a new thing, and but there is possibilities to those companies who are like to do something different and do something a little bit new things. But I think because there is already quite a lot of experience in the Swedish side, how everything works, I think this could be good thing to use more here in Finland also, because you can use it quite many ways only in a standalone equipment for that smaller version, and you can use it to just monitoring your grid connection, because it measures all the phases, all the current and voltage, and check those things. And of course, we have the energy meters in the buildings, but for example, those meters doesn't show the exact peak times, what kind of peaks the loads are doing, and those usually those loads can be quite short term, so you don't need that much battery capacity to lower those peaks if needed.
Exactly.
And and that's the one function. And then you can add PV and also in the future. But I think also it's a good what when we talk about now those smaller residential solutions, but also the industrial solutions, what are at the moment the biggest systems in terms of PV power and size of energy hubs? What kind of projects you have done?
The whole system is scalable when it comes to the energy hubs. So it's 14, 21, and 28 kilowatt in capacity. If you have there are when you're having larger installations, you will have X large, as we call XL modules, as we call in between, and you can mix between 21 or 28 kilowatt modules. So it will come in racks where you put it in. So it's scalable in that case. And the largest we have installed, I think it's 480 kilowatt. So it depends on the reason and what you want to get out of it. Sometimes some clients are mixing, so about 200 kilowatt is with Ferroamp, and then you have the rest with a cheaper converter. So depending on how it looks like. So but the largest one is, I think, is 480 kilowatt. So it's total scalable.
So quite big solutions is possible to do also.
Absolutely, and the racks are in the size of a sort of a refrigerator. It's a computer rack where you're filling. So the large rack is called 42U. It's about 216 centimeters tall, 60 wide, and 80 centimeters deep. And in that one of those racks, we can have 180 kilowatt capacity. So then you can have 2 racks or 3 racks or 4 racks, and so it's totally scalable.
That's good. But and now I take some Finnish. And tosiaan, jos on kysymyksiä, niin kysykää, ja niitä voi kirjoittaa myös tuonne kommenttikenttään sitten, kun tämä julkaistaan tuonne nauhoitteenaan, ja sitten muuta kuin laittaa sähköpostiin kysymyksiä, eli meidän yhteystieto löytyy info@zenergia.fi, teknisissä asioissa support@zenergia.fi, verkkokauppa löytyy p2p-zenergia.fi, ja sieltä löytyy sitten Ferroampin tuotteet ihan eriteltynä, mitä kaikkia komponentteja sinne tarvii. Ja tosiaan muutamia tulevia koulutuksia tuossa mainitakseni. Tuossa on aurinkosähköjärjestelmän suunnittelua 15. päivä Helsingissä ja 16. Tampereella, niin niihin rohkeasti ilmoittautuu, ja ne löytyy tuolta zenergia.fi/koulutus alta. Ja sitten muuhun voi olla suoraan yhteydessä näiden tiimoilta. Kiitos mun puolesta. Thank you to Björn. Do you have something what you want to mention in the end, or?
No, I think I said it all, and you. So thank you, Kiitos, for having me. And I wish you all a very good day.
Thank you. Ja ei muuta kuin hyvää päivänjatkoa, ja nähdään koulutuksissa jatkossakin.